All right, so these are some problems that we started in class on Friday or on Thursday, depending on which day you had physics with me. And my concern is that as I saw you guys working in class, well, to be honest, you guys were slow. And I don't know if that was a function of whether you were tired or not, but we got to pick up the pace because one thing that's going to happen on the exam is you're going to have a lot of problems to solve in a shorter period of time. So you guys worked well, but we need to practice so that you can get faster. So we're going to be working through these problems, and I'm going to go going relatively quickly to kind of give you an idea of the pace that I want you to solve these problems at. So we've done this problem before, but I want to kind of review it again so that you know what to do. And I'm going to do it at the speed that I would want it to be done. So we have a car going from 0 to 60 miles an hour in 7 seconds. We want to calculate the car's acceleration, and we want to know how fast the car went, or how far the car went as it was accelerating. And we're going to do qualitative plots of position, velocity, and acceleration as a function of time. So we've read the question. Now that was the first step. Now the next thing I want to do is label each variable. So I know that this is the initial velocity, this is the final velocity, time is 7 seconds, and we want to get the acceleration in the first part, which is unknown. And we want to know how far the car traveled, so we want to know the final position at the end of the thing. Now, since they don't tell us where the car starts, assume every single time that the initial position is 0. So that's something you need to get fluent at, is understanding that if they don't tell you where it starts, assume that it's 0. So now what I want to do is draw an awful picture of what's going on. So we start here, and we end here. You don't even have to draw the car. If you want to, you can draw a car. I guess it kind of looks like some weird smiley face with a crazy eyebrow, but it doesn't matter. So here's the car, and so we're saying we start off at 0 with a velocity of 0. We wind up here with a velocity final equal to 60 miles an hour. We don't know the final position. We know that the time is 7 seconds, and we know the acceleration is, well, actually we know that it's unknown, so we leave a question mark there. Now we need to convert this, and to convert miles to hour to meters per second, we use the bubble method. So miles per hour to meters per second, we're going to do, so we got 1610 meters in 1 mile, and we're going to have 1 hour is going to be 3,600 seconds. When we put that in our calculator, we end up getting V final is 26.8 meters per second. So, again, 26.8 meters per second. Now what we want to do is this. Let's not guess what equation is correct. So I'm going to do this kind of the long way, the quick way. We're going to plug in every single number into every single equation. So the 3 equations we have, and remember, you need to memorize these. So we have x equals 1/2 at squared plus v naught t plus x naught. So if this seems like I'm going fast in this video and you're a little bit lost, stop the video, write down what I'm doing, and you need to review it and watch the video again and again. So that's kind of one of the things in this class that I'm expecting you to do. You got to step up to the plate and really you got to want this. It's not just going to happen. So we got x equals 1/2 at squared plus v naught t plus x naught, and I'm just going to go in and plug in these numbers. So we don't know x final, so let's plug in the rest of these numbers here that we do have. And let me just go ahead and do that. So, sorry. We don't have x final. We don't have a. Let me plug in the rest of these numbers that we do have. We have 1/2 a times 7 squared plus 0 times 7 plus 0. So when we look at this equation, we've got 2 unknowns. So right now, we can't use this equation. So now let's go on. And what we'll do is, in fact, take a look at the next equation. So we'll move this up a little bit. Now, the next equation is going to be v squared equals v naught squared plus 2a times delta x. Whoops, wrong color. Don't like that color. Change that. So I guess it doesn't let me do that. So now let's go ahead and plug in our numbers. So given what we have here, we have 26.8, whoops, I want the knowns in black, so let's get rid of that. We're going to have 26.8 squared equals 0 squared plus 2 times our unknown acceleration times our displacement, which is x unknown minus 0. So this is also another equation we can't use because we have 2 unknowns. So now we're going to plug into the third equation, and hopefully this one works out. So with that in mind, we're going to have v equals at plus v naught, and we plug in our numbers. We have 26.8 equals a, which is our unknown. Whoops, wrong color again. I just want our unknowns to be in red. That's why I'm fussing around with this so much. So 26.8 equals a times 7 plus 0. When you do the algebra, so you do this, you're going to get that a is 3.83 meters per second squared. Excellent. So now we've got one answer here. Now here's what we can do, because when we read part 2, it says how far did the car go while it was accelerating. What you can do is you can take this acceleration here, and you can actually then take this guy right here and plug it into this formula right here. So for A, what we're going to do is we're going to plug in 3.83. This ends up being 0, and we multiply it out. This is 0. So when we plug A into this formula here, like this, x equals 1/2 times t squared times this 3.83 that we just got, we're going to end up getting here 93.8 meters. That's going to be the answer to that question. So you're expected to be able to work it out that quickly. Okay. Actually, that was a little slow. Okay. For the exam, I want you to work faster and harder. So you're just going to have to. We're going to have to pick up the pace, and you're going to see that on your quiz next time. So this is the position, the velocity, and the acceleration. So we start from rest and we're accelerating. So this would be position versus time, velocity versus time, and acceleration versus time. That's just something you got to be able to do quickly. All right, so that was a really fun problem. Now let's do the next problem. So this is me on Saturday recording videos, and clearly I'm not. I'm enjoying making this video probably as much as you're enjoying watching it. So now we have letter B, which I made you all do in class. So what I just realized is I want to have a calculator ready to go. So let me get that going, and then we'll jump in and do this. All right, so we got this. We have a golf ball moving forward at a speed of 3.5 meters per second as it rolls uphill, so its acceleration was 1.2 meters per second backwards. So first thing we're going to do, I noticed that none of you listened to what I said about drawing diagrams, and then you wondered why you got confused. So we need to be very clear. You will draw diagrams, and in fact, what I'm just going to do on your exam is I'm just going to deduct points if you don't draw a picture. That'll solve that problem. So we have a golf ball moving forward at a speed of 3.5 meters per second, and it's rolling uphill, so its acceleration is 1.2 meters per second backwards. So first thing I want to say, every one of you made this assumption that if I start off with a non-zero velocity, that must be the final velocity. Wrong. What we're saying is the problem starts with the golf ball moving like this, so this is V0. Okay, get really clear on that. Second thing is, since it's moving forward at a speed, and we're saying the acceleration is backwards, we'll say that this is actually the acceleration is negative 1.2 meters per second squared. And then we want to know how far it travels in 3 seconds. And so we're not told an x0, so we'll just assume it's 0. So let's actually draw this kind of situation. So we have this golf ball, and it's rolling uphill. So it starts off here at a speed of 0, or at a position of 0, and we're going to say that V0 is 3.5. And then we don't know what its velocity will be. And we don't know necessarily what its position will be here. We know that the acceleration is negative 1.2 meters per second squared, and we know that the time is 7 seconds. So that's the situation. So you need to have a picture like this. So this is like part 1. So let me go ahead and just set up some equations. So I have x equals 1/2 at squared plus v0 t plus x0. Let's go ahead and plug in our numbers. So I know that x is unknown, and I know. So let me just go ahead, because I think I might actually have all my numbers here. So I have 1/2 times a, which is negative 1.2, times t squared, which is that'll be 3 squared, plus 3.5 times 3 plus 0. So let me go ahead, and when I actually calculate that, I will get 5.1 meters. And since this is positive, it looks like it's going to be 5.1 meters uphill. I'll actually say that. Okay, so that's one thing I do want to see in your answers. Now it says how long will it take for the golf ball to stop. So let's go ahead. When it says for the ball to stop, get this memorized. When it says to stop, that means v equals 0. Okay? And once again, x0 is still 0. Okay, so let's be clear here. New diagram. We have x naught is 0. We have v naught is 3.5. We have an unknown x. Do not use 5.1. You don't know that it was stopped then. So x is unknown. And we don't know the time for it to stop. We know the acceleration is negative 1.2 meters per second squared, and we do know the final v is 0. So let's go ahead and set up our equations. So once again, and in fact, let me just get all the numbers right. So we will have x as our unknown, and we have t as our unknown. So let's see, x equals 1/2 times negative 1.2 times t squared plus 3.5 times t plus x naught. So this is weird. I've got two equations, two unknowns. It's just all these letters, really messed up. So that equation is going to be useless. Now the second equation is v squared equals v naught squared plus 2a times the displacement. And here's the problem. They want us to solve for how long it will take. That's the time. So that equation is going to be useless. So I'm now stuck with the last equation, which is v equals at plus v naught. And let's see what we have. So we have 0. Whoops, wrong color. We're going to have 0 equals a times t, which is, so we have negative 1.2 times the unknown time plus 3.5 as our equation. So now you need to do this algebra and solve for t, and when you do, so you do algebra. I do not do algebra because we are watching the video, so you need to do a little bit of work. When we get time, it will be 2.92 seconds. Excellent. All right. So now moving on to part 3. What will its velocity be after 7 seconds? I want one more picture. So here we go. We have x naught as 0. We have v naught as 3.5. We have time as 7 seconds. We have acceleration as negative 1.2 meters per second squared in seconds and meters per second. Here's some things we don't know. We don't know what v will be, and we don't know where it will be. So both of those things need to be solved for. In fact, if you look carefully, that's 3 and 4. So in part 3, we'll get this, and in part 4, we'll get that. So here we go. Now we'll get velocity in part 3 and displacement in part 4. So let's go ahead and do the calculation. Now, plug in numbers. Once again, do not guess which equation. Just go ahead and solve. So x equals 1/2 at squared plus v naught t plus x naught. Now here's the problem with that. We want to know what its final velocity will be. When we look at these letters here, we don't have final velocity. So this doesn't work. So we want to find final velocity. Why don't we go ahead and use the simple equation? So we have v equals 1.2 negative times the time, which is 7, plus our v naught, which is 3.5. When we go ahead and calculate that, the answer we'll get is negative 4.9 meters per second. What the negative sign means is, another way to say this is 4.9 meters per second backwards. And what I'll finally do for this last one, this is a little bit mean, but most of you got it right. So I'm going to leave it to you to prove that the displacement is 4.9 meters. And that will also, so from the beginning. And this is a coincidence that these numbers are the same. We just happen to get lucky. So that's it for that problem, and we'll do a couple more in the next video.